right. So first of all, I want to thank everyone for turning out this afternoon. And I've been thinking about this entire semester. It's been quite a semester, quite a bit of an experience for us here in engineering. But I would argue, even though the verdict is fully going to be out in probably a week or so, it's been a good experience. We've learned how to use science and measurements and testing and the things that you learned as engineers to manage in-person instruction for the fall. So hopefully by the time we return to in-person instruction, full in-person instruction sometime in the new year with a vaccine and so forth, hopefully, by that time, we'd have developed a bunch of experiences related to interacting with our colleagues in a distance mode. And so it would have been a lot more fun, I know, to see all of you in person, but we're going to do our best. My intention, though, for these town hall meetings is to have them be the beginning of hopefully a number of conversations where in this first meeting, I will essentially introduce myself to this group. And then hopefully in the future, we have a chance to interact perhaps in smaller groups and so forth. So first of all, I've been dean now for 4 months. I came to Cornell 20 years ago, did all my education actually in California. So did my undergrad at the University of Southern California, and then went north and did my PhD at Stanford University. Spent a little bit of time at Bell Labs and have been at Cornell for a little while, for 20 years. My wife is also educated in California, so she did her PhD at University of California, Davis. We have 2 children. Both of them are actually Cornellians. So her son is a sophomore in operations research and information engineering, and her daughter graduated from Cornell a couple years ago. She did a degree in plant sciences and nutritional sciences. So we are sort of Cornell to the bone, but educated on the West Coast. So today, next slide, please. So today I want to spend a little bit of time, talking with you as a new dean about some of the opportunities, I see for College of Engineering in a plan that we're calling Cornell Engineering 2030. And the intention is to lay out for you some of my own aspirations on a 10-year time horizon to talk through some of the opportunities as I see them for the College of Engineering, and to describe some of the threats, things that we have to be careful, thoughtful about to implement in a proactive way, potential solutions. I will tell you a little bit about what we're doing in terms of taking advantage of the opportunities in a so-called bottom-up strategic plan, and I'll explain to you what that means later on. We'll, towards the end, talk about what that means for fundraising, what sort of activities I'm likely to be pursuing as dean to engage you in helping us realize this vision. So next slide, please. So I'm a very driven person. I like to plan. I like to plan towards goals. And as I spent the last year thinking about, what does it mean to take a university, to take a college of engineering at a major university like Cornell, a college that's already widely recognized as one of the top among its peers, to one that's premier? How do you get there? And I've articulated this aspiration in the words indicated to the left of the slide. So my aspiration is that within 10 years, we would have created an engineering college that's broadly recognized as a center of excellence in incubating influential ideas. Those are ideas others follow in education, research, and technology translation. Now, I put the technology translation component in bold because I believe this is really a new domain for engineers and engineering, right? So most engineering schools, in fact, started primarily as teaching institutions where we disseminated existing knowledge. And then in the 1950s and 1960s, many of our universities transitioned to a mode of discovery research. And I think the new domain is where we put these research ideas into practice to translate them into technologies that have impact in the world. And so I see this as a major opportunity for a college, and I'm going to tell you a little bit later on how we're going to get there. Next slide, please. So how do we get there, right? So I argue that there are basically three things we have to do in terms of excellence, right? And three things we have to do in terms of nurturing existing investments and infrastructure, right, to get to this aspiration. So first, among the top three things in the excellence dimension, I think we need to reward and celebrate excellence among our faculty in a mode that nurtures excellence, right? So we tend to be quite understated, and we tend to be quite democratic, if you will, in terms of how we meter out praise, how we meter out rewards. I would like to change that. I think that when people are overperforming as members of the faculty, as staff, as students, we need to reward, we need to recognize, we need to celebrate. And that might sound easy to do, but it's something that I will commit to do as dean, and I believe it will get us on an even stronger trajectory towards the aspirations that I articulated. I believe there's a complementary opportunity to build strength at the interfaces between our different disciplines. I think engineering from its very birth was created as a bunch of silos, right? A mechanical engineering silo, a civil engineering silo, a chemical engineering silo. And many of you would argue that your practice as engineers and in other fields has been anything but siloed. I think it's time for the university to begin to hire faculty that lives at the intersection between fields, to break down these silos, to break down these disciplinary boundaries. And in particular, I'm interested, and I think my colleagues are interested, in recruiting persons who, in addition to being excellent scientists, excellent researchers, are leaders, are trendsetters. The goal is that these persons will come to campus and basically change the culture. They will lead us in creating centers, multi-investigator initiatives that I think will basically activate work across disciplines, because these people will sit at the boundaries between fields. Now, one of the things that attracted me to Cornell many years ago was this shared commitment to excellence in research and teaching. One of the things that some of you have heard me say probably before is that I've been surprised by how little attention we've given to celebrating members of our faculty who excel at teaching. I want to change that. So as a concrete example, if you look around the College of Engineering and you look for endowed chairs that are bestowed upon our colleagues for outstanding teaching, they're probably just about a handful. In contrast, if you look for endowed chairs that recognize your colleagues for excellence in research, there may be 10 times more chairs in that domain. Obviously, this needs to be changed. And so one of the things that I've held as a top priority for my first 5 years in this role as dean is to see every single department in the college have at least one endowed chair that recognizes teaching excellence among our faculty. I think that will communicate in a very loud and clear way that teaching excellence is valued here. How we educate students is appreciated here at Cornell. Now, in terms of opportunities, I think there's a really massive opportunity that has emerged over the last decade, perhaps even 20 years. And this is that engineering is no longer practiced or secluded in the College of Engineering. In fact, some beautiful engineering is occurring in our CALS, or Agriculture and Life Sciences College. Great engineering is occurring in our Architecture, Arts and Planning College. Engineering is happening at Weill Cornell Medical College and at Cornell Tech in New York City. I would like to unify engineering across these fields in what we're calling a one Cornell engineering paradigm that takes advantage of each of these domains and their disciplinary expertise to advance the field in the next 10 years. Now, one of the key requirements to do all of this is that we need to modernize our spaces. In fact, most of the College of Engineering, including the building I'm sitting in, were built in the 1950s and 1960s, when engineering was very different. It was very much mechanical, very big, certainly not wet, definitely not biological, and most certainly not molecular. The world we live in, engineer touches all of these things, right? Engineers become more molecular, definitely more biological. and our spaces need to be renovated, need to be upgraded to keep up with that new paradigm. Now, in addition to renovating spaces, I believe we would need to add at least one new building in the College of Engineering to create new infrastructure that enables new fields. Now, another opportunity is the living laboratory concept, right? So Cornell is exceptional among its peers for thinking of our university as a living lab, as a community where we can actually test ideas. We can use science to understand topics of the day. And in fact, I started with one of those topics, which is how do you keep a campus open during a period of pandemic? We decided to use data science as a way of understanding the options. We decided to do testing and to do smart testing as a way of making the testing economical. And of course, the story has been a success. And I don't want to belabor this point, but we're the only Ivy League engineering college, or in fact, Ivy League university that undertook this experiment, and it's a resounding success. And so it tells one what using the university's resources and using the university experience to investigate how those resources work for problems that impact the world could be influential. Now, Cornell has embraced the so-called Cornell Climate Action Plan, which basically says by the year 2035, the campus needs to be carbon neutral. Now, one of the key uses of electricity in the Northeast, something about 30% of all CO2 emissions in the Northeast originates from heating. We have this ambitious goal of using heat stored in the earth, so-called earth source heat, to heat the campus. And one of the key experiments we've just engaged in is how to do that, how to understand the subsurface at Cornell, how to understand the quality of the heat reserves here, and how to utilize these reserves to heat the campus. And I look forward again to discussing that more with you. Next slide. So as with any new opportunity where you have, major ideas, right? I articulated 6 different concepts that I think could get us to our aspiration. It is useful to think about what are the attributes of the institution. To some extent, what are our values that are going to guide actions towards these goals? So I indicate some of the attributes at a glance, so to speak, right? So we are about, 3,200 undergraduate students. One of our key attributes in that domain is that we've become extremely diverse as a College of Engineering at the undergraduate level. So currently we're on average 50% women. So we are at gender parity in the college. We're about 19 to 20% underrepresented minority students in the college. And the number I want to draw your attention to, which actually struck me as quite remarkable when I saw it for the first time, is a number in curly brackets towards the bottom, the BSW number. That basically says that of every 100 bachelor's degrees awarded to an engineer in the United States every year, 1.2 of these degrees is a Cornell degree. So in other words, we're graduating just over 1 in 100 of every woman engineer in the United States every year. And to me, that tells you that this is an influential organization if we do that well. Now, the situation translates even more spectacularly at the PhD level, where again, our numbers of students are not large. But if you look at the demographics, we're graduating roughly 1.4 of every 100 PhD students in the United States every year. Again, it says that this is a College of Engineering that can aspire to be influential. Finally, among the faculty, I like to say we're certainly not as big as Georgia Tech, that has over 400 engineering faculty, and certainly not as small as Caltech, which has about 80 engineering faculty. We're somewhere in the middle, but our faculty are known throughout the field for their rigor and their commitment to excellence. Our weakness is that we're not as diverse at the faculty level as at the undergrad or grad levels. And this is an opportunity, I think, for a new dean to have an impact. Our faculty members tend to be somewhat understated. And I think to be influential, you have to be out there, you have to be visible, your work has to be recognized by your peers. And the statistic in the curly bracket I'm showing here in this domain relates to the number of our faculty that have been inducted into the National Academy of Engineering, which is the sort of highest accolade that you can give to an engineer in the United States. That number used to be 29 around 2000. It has steadily dropped to 8 as a number of our faculty members who held that honor have been retiring. Obviously, we need to reverse that if we're going to be influential. So I think we have excellent students. We have student populations that are diverse. And if we nurture these populations towards excellence, we have the ability to be influential in the country. Likewise, at the faculty level, we have this foundation of rigor and excellence that I believe if we can build into that fabric, faculty members who are perhaps more visible, who are more recognized, who are more celebrated, I think these are domains in which we can very rapidly advance our college to the next year in terms of excellence. Next slide, please. So in addition to the people, right? So that's, I just talked about people, students, faculty, and composition and characteristics. I believe our college is invested in the right domains. And so what this chart basically shows you are the areas of strength on the left. So advanced materials, bioengineering, computer science and data science, energy and the environment. These have been pillars of strength at Cornell for the last 30 years or so, which basically means we've built infrastructure and we've hired people in these domains. Now, the right of this chart basically gives you the top 10 of a list of grand challenge questions for engineering that was published by the National Academy of Engineering in the year 2008. So affordable solar energy, energy from fusion, food, water, and so on. And what you will notice with the lines is that our faculty expertise intersect these grand challenge questions multiply. And in fact, it's deliberate in this construction that these lines are reflected lines, right? Meaning that there's an opportunity for impact in one domain to influence another domain. So we've made the right investments in people. We've invested in the right areas in terms of impacting the real world. And the questions, the grand challenge questions that humanity is likely to face in the 21st century are questions we're well prepared to address. So again, I believe we've got the ingredients as a College of Engineering to be influential. Next slide, please. So then what keeps a new dean up at night, right? So I've told you great things and hopefully you agree with me that our college is well positioned to be a great College of Engineering, perhaps even greater than the time when you were here as a student. So what keeps me up at night? So what I'm showing you on this chart are basically two types of rankings, right? Both made by the same organization, the US News and World Report. The rankings to the left are basically the undergraduate rankings. The rankings to the right are what are called the graduate rankings. Now, these rankings are actually accumulated using very different methodologies. And so let me spend a minute walking you through the respective methodologies. So for the undergrad ranking, basically it's a survey, right? So every year, roughly around this time, US News and World Report sends out a survey to academics, deans, senior faculty at every engineering university in the country, and says, you know, on a scale from 1 to 5, how do you rate all of the different universities, right? So they might rate Cornell a 5, Stanford a 5, and so on. And out of that ranking, US News and World Report creates a sort of GPA. And based on where you stand in that GPA, a ranking is given. All right, so that is the ranking to the left. The ranking to the right is a little bit more sophisticated. About 40% of that ranking is a survey ranking, much like I just described for the undergrad ranking. But the remaining 60% reflects things like research activity of the faculty, how many awards your faculty have received, how many publications they've authored, how many PhD students do you graduate in a year, and so forth. Actual metrics of activity in the research domain. Now, if you look at our rankings in the left box, these are the undergrad survey rankings over the last several years, from 2018 to 2021, you will see that the College of Engineering, indicated in red, we are ranked roughly 9 or 10. So we were in the top 10 of engineering schools on a reputational basis, a survey basis, but very close to the top 10. So we are not 5 or 6, but very close to the upper bounds of the top 10. programs. And what is more important is if you look at this number over time, you'll see it's more or less stagnant, right? We're either 9 or 10. Now, in contrast, if you look at the rankings data, remember these rankings on the right are gotten by a combination of survey data and actual quantitative information about activity. The Cornell engineering numbers are in blue, and the time axis is the bottom axis, the bottom horizontal axis. And what you'll notice is that our rankings have actually been getting progressively worse over time, right? So when I got here, we were ranked roughly about 7th in the country. Now we're ranked consistently in the range of 13, 14 in the country. Now there are over 200 schools rated in this ranking, so you might say that's not bad, but in reality, it's very different from the rankings to the left, right? Rather than being stationary and solid, we've been slipping. And this obviously means something is going wrong that we need to correct. Now, as a point of reference, I'm showing in this same plot the same rankings, but now for the entire Cornell University in red. And you will notice that these are also slipping over time, but the slope of the blue line is actually steeper than the slope of the red line, which means that the College of Engineering has in reality been slipping faster than the university as a whole. My objective as dean is that in the first 5 years in this role, I would like to stop this decline. I would like to see us reflected in the top 10 solidly in the ranking to the right. And my thinking is that if we do that right in a strategic way, then we should be able within the 10 years from now to the end of the 2030 plan, we should be able to move the university back to where it was when I started as a faculty member here in the range of the top 7 or 5 in the country. I know this might seem like a tall order, but I'm a committed person, and my faculty in the college are committed to seeing these trends reversed. Next slide, please. So one of the key challenges is that commitment. To honor that commitment requires us to hire faculty members who are doing frontier research in new domains. And as I indicated to you, much of our infrastructure was built when such research was not even conceived. These buildings were not designed to do any of the things that we will need to grow into to be successful. But what I want to communicate to you is that there is a strategy that seems to be working, and I show this by means of an example. So the example I show here is Olin Hall, which many of you may not know, is the first building built on the engineering quad, so built in 1941. So Olin is the home of chemical engineering. And Olin, oddly or curiously, was designed by the same architect that designed the Empire State Building. I don't know how many of you know that. So I say that to tell you the building has pretty good bones. It may not look like the Empire State Building, but it is extremely well built. Case in point, in 2019, we received a very nice gift from an alumnus, Sam Fleming and his family, a gift of $10 million. And the director decided to basically take this old building and create a wing in this building called the Institute for Molecular Engineering that is now one of the top set of laboratories for doing that kind of engineering now in the country. So my point is that even though our infrastructure is old, with creativity and with your help, there is a mechanism by which we can reinvent these buildings, essentially one unit at a time, to get us to the goal of creating spaces where we can do innovative science research. Next slide, please. Now, obviously, this all can't be done willy-nilly because in reality, we have constraints. Some of the constraints are infrastructure. Some are already investments we've made in people in the 4 domains I mentioned before: materials, biotechnology, computer and data science, and energy and the environment. And so we need a strategy. So one of the first things I did, this is started on the 30th of July, basically 30 days after I took on this role, is pull together our faculty around an exercise in planning for a future, planning towards achieving this 2030 vision that I articulated. Now, I'm a firm believer in the concept, to lead is to serve. And I believe that fundamentally, if the College of Engineering is making investments that are going to advance the goals of the departments, the goals of the faculty, the aspirations of our students, those decisions have to be made in tandem with stated aspirations from the faculty, from our students, from our staff. So we've implemented what's called a bottom-up plan that begins in the green layer, step one, with every unit thinking about itself, looking introspectively, looking longitudinally, thinking about how do we compare? What are the best schools in our domain? What is it they're doing that we're not doing? What sort of things, what activities are we doing that are not useful, that might be outdated and should be discarded? Which one should we invest in, right? So fundamental things to figure out, where are the places that you can grow and build in a strategic way to have the impacts we would like. And then after that stage, figuring out what investments are required to get there. And thinking in a somewhat inverted way. What does success look like, right? So if we do this thing, if we implement this plan, if we choose these areas, what does success really look like for our students, for our faculty, for our staff, in quantifiable ways? And how do we measure progress towards our goal? How do we evaluate success? My goal is relatively ambitious. I would like by the 1st of October of next year to actually have a plan that we can share with the community so you can see where we want to invest, how, and why. And the intention is that once we have that plan in place, we will run very hard as a community to implement the tenets of that plan with the goal of getting to our overarching aspiration by the year 2030. Next slide, please. So in the next couple of slides, I want to talk through some of the key elements, I think, that will allow us to partner together with persons on this call to get to these goals. And I want to do that within a structure that has actually become very popular on campus, that was implemented by our Alumni Affairs and Development team. And it's so-called big ideas, right? And so the idea is that, we're always saying we're the best at this and we're the best at that. And what the Alumni and Development team did quite wisely and astutely is to say, why don't we think of things that Cornell University is uniquely positioned in the country, perhaps even in the world, to do? And to not think of it in the siloed way we've thought about things in the past, to think about how do we collaborate, in fact, across campus boundaries? How does Ithaca and Weill Medical College or Ithaca and Cornell Tech collaborate to activate these big ideas that can impact society and impact humanity? And this has excited the faculty because it now involves them in thinking about where are we really good and where can we really have large-scale impact that unites the university. So I list a few examples and I would be happy to discuss them in detail. So the Engineering Leadership Program is a big idea. In fact, we're one of the few universities, maybe the only Ivy League university, that has integrated leadership education, things that used to be called soft skills, as a fundamental characteristic in the undergrad engineering curriculum for win-win outcomes for those of you who participated in that program. The Commercialization Fellows Program is a winner, where we understand, as I said earlier, that it's no longer good enough to just invent and discover new things. You've got to figure out how to translate these new things into the marketplace to make products that can compete in that market for societal impact. Institute of Quantum Information Systems. You've all heard about quantum computing. We want to develop the materials and the information systems that essentially enables the transition to the big, fast computers that quantum computing is going to presumably get us towards. We have a concept for an Institute of Product Design and Manufacturing, a Center for Data Science and Artificial Intelligence, an Energy Systems Institute. These are all institutes designed to take big ideas, things that will have big societal impacts, and unite our faculty around these ideas across campuses. Now, what will it take to succeed? And how will I interact with persons on this call and in this group to be successful? Next slide, please. So this is how I want to interact with you, right? So I said that, the very first thing I want to do is to reward faculty excellence. I want to hire exceptional faculty at the intersection between these siloed boundaries. Now, to do that, we have to spend funds starting their research careers. We often have to invest in attracting these people from other universities. And so endowed chairs is a really nice opportunity for us to have impact in that domain. Now, teaching excellence, I hopefully have convinced you that I'm serious about um, codifying, about embracing, about celebrating excellence among our teaching faculty. What I would like to do is, again, to recognize that by actually endowing chairs that supports excellence in teaching, including chairs that provide stipends to these faculty members that allows them to write the next textbooks, to mentor the next generation of students who might then go on to be teachers in their own right. Student support, I argue that students, graduate students, postdocs are the lifeblood of the research enterprise, and anything you can do to facilitate us doing that, that is obviously enabling towards our aspirations. Infrastructure space, whether these spaces are renovated space as the Olin Hall example, or they're totally new spaces. This is something we absolutely need partners to be able to do. The living lab concepts, this is extremely exciting. The Earth Source Heat Project, I think, has the ability to define a model for heating cold climates throughout the Northeast and perhaps in Northern Europe, where the electric power renewability is a whole lot easier than heating renewability. And so if we were able to develop this project to the point where we can demonstrate how, when, and why it works, we think the living lab experience at Cornell could be translated for impacts globally. Now, I mentioned that one of the attributes, one of our values as a college is our diversity. And I would argue that that is a value that it has come to light in recent times, in recent decades in engineering, but it's an old value, right? So any person, any study, that's what that value was about. And to some extent, it is great that we're now, as a college, we're kind of caught up with the notion that if you educate a student body that reflects the composition of students in your society, you have a better chance of educating well-trained engineers. And so that's exactly what we're doing now. We need to build on that by basically creating mechanisms for these students to thrive while they're at Cornell. And I believe if we do that, there's a kind of virtuous cycle we enter, right? Where the students who come here and are successful then become the ambassadors that attract students to continue this tradition of diversity in the college. So it's a high priority as well. So this is everything. Next slide, please. So this is everything I wanted to say to you. Hopefully I've given you a perspective on how I think. I've given you a sense for my own deep commitment to excellence in all the domains we enter into as a College of Engineering. And I've hopefully communicated to you what concrete steps I think we will need to implement to reverse the slippage that we see in the rankings that are quantitative. And in so doing, I think the elevator college rightfully to a university that is influential and perceived to be broadly so by our peers. So I thank you for your time and look forward to answering any questions that you've got.
Thank you so much, Lynden. I'll just remind everyone to raise your hand digitally, raise your digital hand in the chat, or also offer your question in the chat. There's a couple here that I'm going to start with, Lynden. From Jose Ramos, will Cornell offer a free online artificial intelligence course? Stanford, MIT, and now Harvard are doing this. I find that these state-of-art courses are attractive to aspiring engineers. The best students are self-learners.
Stay tuned. That's all I can say. We are, in fact, right now in a conversation. I think you, Jose, you know that we are a little bit late to this thing, right? To online instruction. We have some centers of excellence, right? So we have an extremely good distance learning program in systems engineering. And recently, eCornell has come onto the campus. So eCornell is now part of the university campus. I think those two vehicles gives us the sort of infrastructure we need to deliver content. And I think the experience teaching during the pandemic, I believe, has given the faculty the confidence that we can deliver courses at the same quality of our in-person courses. That's very important to me. I believe that um, everyone is running to this game, right? Everyone thinks that this is an opportunity. And, and often it's being viewed as an opportunity, not in the spirit of what you described, Jose, but an opportunity that's financial. I believe that if we do this incorrectly, it hinders our brand and it basically diffuses the opportunity that you see. So I want to do it right. And so we're going to do it strategically and deliberately, but stay tuned.
Thanks, Lynden. Two questions from Albert James that I'm going to combine. Of the 19.8% URM, how many of them are African American and or Hispanic American engineering students? And he also asks, how does Cornell Engineering support NSBE, SHPE, and SWE organizations to help achieve the goal of diversity?
Yeah, so so of the 19, so remember the 19% is an average, right? So of the 19%, roughly 11% are Hispanic, and about 7-ish% are African American. Cornell Engineering does support all of the organizations you mentioned. And in fact, in my previous life, before I became dean, I was the department head of chemical engineering. And we used to be very proud to say our students were the presidents of all of those organizations at the same time, often. And so we embrace these organizations for precisely the reason you indicate, that they provide a way for students who are underrepresented to interact with networks that are cross university. And if anything, we need to be investing more in those organizations.
Thanks, Lynden. Howard Miller, Operations Research 89 graduate and a parent of 2 enrolled engineering Cornellians, notes that after the success of the fall semester, he shares some concerns about the lack of in-person teaching this upcoming spring semester. There was an article published in the Daily Sun on December 10th, and from his perspective, confirmed in his eyes after this week's pre-enrollment. So I think he's asking, what the balance of in-person versus, virtual teaching might look like in the spring.
Yeah, well, so we can only hope, right? So the approach we've taken is one of faculty members can opt in to do in-person teaching. And the idea is to keep it open. And part of it is that, these are serious times, right? And we don't necessarily know what health exposures or pre-existing conditions different faculty members have. The experience of the students who attended in-person instruction has been across the board quite positive. I hope your children felt that way. And so we expect that from the student side, the demand is going to be there and the demand is going to be high. Now, obviously, we've turned a corner nationally, right, with a vaccine now being available. It is not clear when teachers are going to get that vaccine, how far down on the line we are in that process. But, my own thinking is that, the thought that we, at least have our hands around this problem, right? We have a technological solution to the problem of transmission and runaway infection will give members of our faculty who are perhaps reluctant to engage in person a little more confidence about in-person instruction. So right now we're hoping that the number of faculty members wanting to teach in person goes up, but we have really no interest yet in forcing people to do that.
Thank you. Rick, go ahead, Howard. Yeah.
Thank you, Dean Archer. My children had a phenomenal experience, both a first semester freshman and actually a last semester senior who'll get his MEng next semester. And they had actually a surprising number of in-person experiences, which is why my expectation was so high.
Yeah.
And again, I don't want to derail this conversation. It's just that they have almost no in-person instruction scheduled, and hopefully that can change. So I'm optimistic, cautiously, but hoping that what we see in these early days will not be what ultimately happens come February.
Yeah, well, I'm being nice, but I'm cracking the whip because that is of course what I would like to see too. I think that it is interesting that your children are exactly at the beginning and the end, where the faculty members who've taught in person say they in fact get cheers and the students are
Yeah.
quite appreciative of the effort. And so hopefully, again, those attitudes will bubble over to the spring to provide even more inducement to faculty members who are reluctant. But I expect it will be better, but just that, again, we're keeping it open to the faculty to opt in.
Thank you. And thank you for your vision. It was
Yeah, great question. Yeah.
Thank you.
Rick Kochalis, I'm not sure if I said that correctly, so apologies if it was mispronounced, notes that he thinks that this is an impressive vision and plan of strategic action. Along with the strategy complement, Jeff Lauren asks, back to the strategy slide, your pyramid, he would offer that steps 2 and 3 in the pyramid could be reversed. Identify what success looks like, then identify necessary investments. And once that's done, focus on the appropriate metrics of progress toward that success. I don't know if you want to have a comment there.
No, absolutely right. So in fact, I would, so I tend to think in a kind of inverse way. So step 3 is actually my step 1. That if you're going to engage in any kind of planning, it takes effort, it takes work to do a good strategic plan. You better have a good idea of what success looks like that justifies that investment in time and resources and so on. So you're absolutely right. And just so you know, the pyramid is just sort of a guide to the eye. And it is intentionally, bottom up, meaning that the departments are deciding, what their pyramid looks like, right? Do they even have a pyramid in terms of how they define their strategy? But what we are doing, though, is insisting that every department benchmarks itself against excellence, right? And not just in an abstract way, not to just come to the dean to say, I'm the best at what I do, but come to the dean to say, on the largest collections of rankings you can find for your discipline, and there are many now out there. I just showed you one, the US News and World Report rankings. Who are rated in the top 5 in your discipline? And what are the characteristics of these places that are in the top 5? And how do you measure up on those characteristics? And what will you do to make sure that in 5 years, you outperform schools that are in that top group? And so it's a deliberate plan, one that I'm frankly quite excited about, because I think it gives us an opportunity to take on issues of curricula, research domains that have become outmoded in a head-on way to say, you know what, these things might have been good to engage in, but we will never be first in class in this domain. Perhaps it's best to invest somewhere else. And that, for a dean with finite resources is precisely the kind of direction in which we want to go.
Thanks, Lynden. The next one I can probably field. George Clare has asked, we've highlighted opportunities for fundraising. However, many alumni have more to contribute in terms of talent versus money. Are you similarly working to develop opportunity for alumni to contribute with their time and talents? During these days of virtual life, it would be much easier for distant alumni to join versus times when much is done only in New York State. George, that's an excellent point, and I would just offer that we have a robust slate of programming prepared that we put in play for the spring semester. We've also recently launched a webinar series called I Am a Cornell Engineer. I'm not sure if you've seen advertisements for that, but we've done 3 of those talks so far. We also have a very robust volunteer engagement and volunteer opportunities and engagement network across the entire university. And I would encourage you to reach out to me or Christy Blake or any member of my team to talk with us about where you might plug in. So in short, the answer is that your time and talent are equally important as the treasure that you might invest in the future of the College of Engineering. Lynden, I don't know if you have anything to add.
Yeah, I will add just one thing that's important. So I have a group of undergrad students that advise me about, where are the things that are good, what is bad. And I met with that group on Friday. And one of the things that they flagged as an area where we can improve is actually professional counseling, professional advising, especially early on, right? Like, so sophomores want to know, what does it mean to be a civil engineer? What types of careers civil engineers pursue? In chemical engineering, we have a course, actually a required 1 credit hour course, Chemi 3010, that's called Chemical Engineering Careers. And in that course, literally every week, an alumnus comes back and talks about, where their chemi degree took them. And this provides a really nice platform for students to begin to plan their own careers. There's an interest in perhaps doing something like that across all engineering fields. So to have one like that in mechanical, one in civil, and so forth. And I think, as you said correctly, now we have the ability to do some of this instruction in a distance mode. We maybe even have a way of creating a learning library where we can curate a set of videos that are pre-recorded. So there are lots of really new things and new ways in which we can leverage your expertise and your time to enrich the student life here on campus.
Thanks, Lynden. George Shapiro asks, related to chemical engineering, is chemical engineering continuing to downplay the classic chem eng curriculum that relates to the chemical process industry? Will any chem eng be able to design a chemical plant in the US if one is ever built, or are we guaranteeing the engineering skills will be globally sourced?
That's a great question. And that's a question that it's timely, right? And timely in part because we did an experiment in chemical engineering probably about 7-8 years ago around process design versus product design, right? I think, George, you might remember as a student, all chemies were basically given a product, right? A product might be make styrene and make it in a certain scale, and to build a plant that makes it, so you do all the reactions, you do all the economics and so forth. But increasingly what we find is that students who leave the chemical engineering program, they end up actually not being given a product. They have to come up with a product that can compete in the market. And there's some totally different skills that requires, right? Including discovery, customer discovery, and so on. And so we did a head-to-head for several years, and the students have literally spoken with their feet to indicate that they're as much interested in designing processes as they are in products. And what we've done in chemical engineering is preserve the rigor of the core curriculum, but bifurcated the student population at the very end. So instead of the capstone design being probably the one that you experience, the design of a chemical plant, it is now design of a product as well as a process.
Thanks, Lynden. Paul Hare, hi Paul, thanks for joining us. You are targeting October by which to have a game plan for how to hit your objectives for engineering next October. What do you want from alumni during that development process? Or asked another way, what role could alumni play in helping you shape that plan? Execution is a separate topic perhaps, but best saved for later next year.
Yeah,
Thanks.
yeah. So, Paul, right on target. Yeah. So, so what we envisage is that as the plan begins to come together, it's going to be important to, and I'm going to use a word, socialize it in our stakeholder communities, right? The communities that winning, right? So we need to figure out, is this plan really going to address the shortcomings, the opportunities that our alumni population see? Now, the plan, at least right now, is to do town hall events. I don't know if exactly like this, Carol, but events like this periodically to update you as we make progress. And before October, the intention is to do them more in a kind of fact-finding, advice soliciting mode, which I guess is complicated to do with a big group. We're going to also use the Engineering College Council, which many of you know is the group that of alumni that directly advises the dean to give sort of more focused feedback on aspects of the plan. And on the implementation part, as I indicated, a good plan has to have quantitative metrics, and it has to have a process for managing progress towards those metrics. And so again, I anticipate whether I interact with you in the future in person or online, you will see a systematic strategy that advances what have been done and what needs to be done to get us to our goals. So stay tuned.
So there's a question about the returning nuclear engineering as an important part of our curriculum based on energy and climate change initiatives globally. Specifically, George Clare is pointing out that Bill Gates' TerraPower is a good example. Any thoughts on whether or not nuclear engineering will become part of the curriculum again?
So George, great question, right? So I am an energy person. I used to lead the Cornell Energy Systems Institute, and I'm very much an all hands on deck kind of person, like all of the above strategy. And in terms of baseload supply of electric power, you know that nothing really beats nuclear. There's obviously a safety dimension to nuclear fission technology that makes it extremely expensive to implement. So this, I would argue, the global trends, the global attitudes towards nuclear fission technology parallel almost exactly the decline of nuclear engineering as a discipline in the College of Engineering. Remarkably, though, what has actually emerged is technology, interest, expertise that is relevant in the fusion space, right? And this is where the Gates investment was. In particular, we have a world-class lab of plasma sciences that have discovered this business of inertial pinch that ends up being very important in terms of confining that fusion reaction. And we just started a search to hire the next leaders of that entity. And what I explicitly advise the search committee is that we're looking for a person who can bring others together to develop technology in that domain. In other words, we're not going to be hiring 20 faculty in nuclear engineering, but we're going to be hiring a superstar in plasma studies, an area where we think we can have tremendous impact in fusion technology. And we're going to be hiring a person who can work with a material scientist, can work with a mechanical engineer, can bring them together so we can create critical mass in this important domain. So it is a field of importance. It's one that we have to thread on a little bit gingerly because the technology is about 50 years, some would argue, to maturity. But it looks like we have a role to play in the college.
Thanks, Lynden. A couple of comments and then one question, and then we're close to time. Henry Goldberg has a shout out for the Engineering Leadership Development Program with an effective strategy for Cornell engineering. It should not only be done for undergraduates, but should also be developed for graduate students, including PhDs. I think that, speaking for Lynden, he agrees with you wholeheartedly. Yep. Tom Dewey just points to the fact that engineering alumni in the Southwest are invited to engage and network professionally. He's left Greg Power's contact information in the chat if you want to take a look at that. Programming starting in Q1 of 2021. And then there's a question from KAB, I'm not sure who this is, but he or she asks, my daughter applied to Cornell Engineering, and one of the things that caught her eye was the 50% female statistic for incoming students. I'm curious what the graduating statistic looks like. What % of the graduating class are female? If there is a drop-off, can you share why that might be?
So it's 50, it's actually 52%.
It's the opposite, right?
Opposite. So the drop-off is unfortunately on the other side. But it's minor. In fact, this is I didn't state that as a success metric because there are just so many. I mean, our graduation rates are off the charts. They're upwards of 90%, and I think part of it is that we are very careful, in the filter, right? So I gave you the raw numbers, right? But I'm going to just give you an illustration of the quality, right? So the class that started in fall 2020, that class was 52% women, 24% URM, and 15% first-gen students. And among those students, I like to say this, so this is incredible, like more than 90% of these students were in the top 10 of their high school graduating class. So in an interesting way, the raw material that we bring in is exceptional. And the program that we develop around them is kind of structured and it's intentional. And so we build students with the right electives towards the right goals. We've learned over time, that all students don't learn in the same way. We've learned that even the spaces in which students learn can impact the quality of how they assimilate knowledge. And we've developed structures through our McCormick Teaching Excellence Institute that allows us to kind of activate that around expert teachers that has improved the quality of the teaching. So again, there are lots of really nice success stories to report around matriculation and around gender diversity and racial diversity in our student population. We've got to do it at the faculty level next.
Thanks so much, Lynden. I think I'm not seeing any other questions or hands raised, and we're almost at time anyway. So I don't know if you have any closing words for this group, and I would just like to say thank you to everyone for participating today, and then I'll turn it over to Lynden to close us out.
Yeah, absolutely. So same, Carol. So I just can't wait for the time when I can come out there and interact with you in person. I know that Zoom does its own kind of filtering, and they're questions I bet some of you might have had if we were pressing the flesh and speaking, that are important questions that at some point I hope I have an opportunity to engage you in person. I like the comment about contributing of your time and of your intellect. In fact, I've always found that to be the more important way alumni can influence existing students. And we have a lot of initiatives. I mentioned the one at the undergrad level. We were thinking of an analogous initiative at the Masters of Engineering level to create networks where our students could benefit from your own experience. So again, please stay tuned. All right. So happy holidays, stay safe, and all the best for 2021.